need Desmos. Can you see? Okay, good. All right, so today I hopefully got my email. So we don't have class on Monday. So if you haven't seen that yet, we don't have class on Monday. Today we're going to go over 9.5, which is hyperbolas. And then I'm going to actually send a recording out for 9.6, which should be pretty easy to watch because it's just basically circles, parabolas, ellipses, and hyperbolas when we shift them around. So we're just basically translating them on the graph. So it's just kind of moving them around. So I'll send out a video with that. And the homework's just 3 through 13 odd. So that should be pretty easy. And then next Thursday, I'll be online for class again. So for Monday, like I said, everybody in the email, just go somewhere that you're allowed to go, or maybe sleep in later, or hang out wherever you can. But I'm available online too. So, all right. That's what's going on schedule-wise. So we have talked about parabolas, all right? We got our parabola. We have our focus point right here on our parabola, and then we have our directrix, which helps us graph that. And we kind of learned how to do those. Then we talked about circles, which circles were pretty easy. And then on like last Thursday / Monday, we talked about parabolas, right? So, or parabolas, ellipses. So an ellipse is kind of like a circle and kind of like a parabola smushed together, right? You have this parabolic shape on each of the edges, but then you have the idea of the circle where it's complete. And we talked about the different equations that have to do with ellipses, and that ellipses have these two focus points, just like a parabola has one focus point. And that if you take the distance from the first focus point to the ellipse to the second focus point and add them together, it's a constant number. Okay. And then we talked about how to identify the parts of that. Well, this next section we're going to talk about is hyperbolas. So hyperbolas have a lot in common with ellipses, even though they look nothing alike. So a hyperbola looks like this. It actually looks like two parabolas that are opposite each other, that are like reflected across an axis. Can be either the x or the y axis. So it's kind of like you took that ellipse that the two arcs were opening in, and instead we're going to open the parabola arcs out. And there's a lot of the same terminology and the same feeling that you'll get from parabola and ellipses when you get to hyperbolas. Okay, so the first thing to understand with hyperbolas is that we also have focus points, or the foci, right? That means the 2 points. Excuse me. But what's different, so remember in an ellipse, if we added the first, like the distance from the focus point, the first focus point to the ellipse to the second one, and we added them together, it was a constant. Well, when you're talking about a hyperbola, you actually, if you subtract the distance from the first focus point to the hyperbola minus the second focus point to the hyperbola, then that's a constant. So that's kind of the difference if you're actually, that's the difference between the ellipse and the hyperbola when it comes to that. When it comes to actual hyperbolas, though, there's a lot of the same terminology, just a little bit different here. So let me put this in paint so that I can draw on it. Okay, so just like with an ellipse, we can have horizontal or vertical hyperbolas. Okay, so this horizontal hyperbola, actually, you can see here, kind of makes sense because, and there's so much on this graph, but our actual hyperbola, if we graph it, is, let's see if I can do a better job of drawing my line here. This is the actual graph that we're talking about, is this one right here. This is what we actually want to look at. Okay, if I could draw that correctly. So if you graph a hyperbola, what you're what's going to show up on Desmos is this red line in a much nicer fashion than what I have. And then everything else is just the labels that go along with this. So let's just look at a horizontal hyperbola, and I'll point out some of the features. So again, this kind of draws from parabola and draws from ellipse and comes up with a hyperbola. So the first thing you'll notice is that on our hyperbola, we have a vertex. Okay. And it's basically like the lowest point or highest point or least point or most point. So we have a vertex, and that's just like if you have a parabola, right? If you just have a parabola, you have your vertex point that's kind of where the line of symmetry goes through. It has a lot of different features to it. So we talked a lot about the vertex, so you have that. Same thing, except you're going to have two of them, because when you have a hyperbola, you have the reflected across an axis. Excuse me. You also have a focus point, which again is just like a parabola, right? When we have a parabola, we have a focus point. But since we have basically two parabolas, we have two focus points, one on each side. Okay, so those are pretty self-explanatory, I guess I want to say. They follow from what we know from parabolas. They're pretty much similar. That's what I'm trying to say. Okay. We call the axis, since this is a horizontal parabola, we call this the transverse axis because this is the one that they go across. Okay. It's our transverse axis. There are two other points here that are labeled that are 0, negative b, and 0b. Those become important because all hyperbolas have an asymptote. So an asymptote, remember, is a line that they get really, really close to without ever crossing over. So that's what's shown in this. I'm going to switch colors. Let's see, yellow. I'm going to use a line tool. There we go. All right, so if you look at this dashed line here, and this dashed line here, much better, those are actually the asymptotes of our hyperbola. So our parabola shape, right, this red shape is going to get really close to those asymptotes, but it's actually never going to cross over that. And we find these asymptotes by using our vertex, okay, and this point B, which you'll be able to calculate, and that actually gives us the equation of our asymptote. So you'll see that down here, that, and I actually didn't introduce it. The equation of a hyperbola is x squared over a squared minus y squared over b squared equals 1. Okay, that's the equation. If it's a horizontal hyperbola, then the asymptote is at y equals plus or minus b over a times x. So that's where the vertex of this hyperbola becomes important. Okay, so you'll notice that this equation for a hyperbola looks really similar to the equation for an ellipse, right? So basically the difference between the equation for an ellipse and the equation for a hyperbola is if this is plus, then it's an ellipse. And if you take that away, oops, then it is a hyperbola. That's the only difference between the two. Okay. And if it's a horizontal ellipse, then your bigger term goes under your x, right? If it is a vertical, then your bigger term goes under your y. So they feel very similar. It's just kind of a change of signs between the two, between an ellipse and a hyperbola. So hyperbolas you're subtracting your terms, where ellipses you're adding. Okay. And then down here, you can see we have our good friend, the foci, the focal points, right? When we were finding the equation for when we were finding where the focal points were in an ellipse, it was c squared equals a squared minus b squared. Oops. And you'll see for a hyperbola, the foci, the focus points, are c squared equals a squared plus b squared. So it's a lot the same that you're going to do. It's just a little bit different. So let's do a couple examples. Again, you are going to have these notes available to you when you take your test. So I'm not expecting you to memorize, the asymptote of a vertical hyperbola. Tell me what the equation of that is. But I do want you to understand what the key features of a hyperbola are and how to find them. That's kind of the goal of this chapter. All right, so if you have your notes in front of you, number 1, we have, I'm trying to find my pen here. So we have x squared over 16 minus y squared over 49 equals 1. Okay, so what I want to do is identify the vertices, foci, and asymptotes of my hyperbola. Okay, so you actually can graph this without a graphing tool. And just like when we were doing ellipses, we want to figure out which graph it most looks like. So these are actually a little bit easier to pick out because you'll notice the equations are flipped a little bit. So in the other one, it was like kind of whatever the bigger number was, tells you if it's horizontal or vertical. This one, when it's horizontal, your x is your first term and you're subtracting by your y squared. When it's vertical, your y squared is the first term and you're subtracting by x squared. So this one is pretty easy because I know it looks like my horizontal hyperbola. So what that tells me is that this matches up with my horizontal formula. So x squared over a squared minus y squared over b squared equals 1. Okay, so that means a squared equals 16 and b squared equals 49, or a equals 4 and b equals 7. So now if I actually wanted to graph it, I actually could graph it just based off of a couple of pieces of information. So my vertex is at A0 and negative A0. So 1, 2, 3, 4. The vertex of my parabola is here at 4, right? This is very crude. Trying to do it fast here. And at negative 4. Okay. So I know that that's where my my vertex are. I don't know where my focus points are, but I can find those. I also know that my asymptote, okay, is at y equals plus or minus b over a times x. So 7 over 4 times x. I should put that in a different color. So if I draw my asymptote, right, I'm going to rise 7. Oh, I didn't do a very good job graphing here. If I draw my asymptote in, it's going to look something like this. And this is, again, very rough. So then when I go to draw my hyperbola, as long as I follow along my asymptote lines, oops, then I should be able to draw my hyperbola. All right, let's go to Desmos, which will do a much nicer job than what I just did. Okay, so I know that I have if it's going to work for me. I know that I have asymptotes at y equals negative 7/4 times x. And I wonder if I can do plus or minus. Let's see. Nope, doesn't like that. Okay. All right, so I know that I have asymptotes here at these two values, and then I know that my parabola actually starts at 4 right here. So actually I could draw my parabola, well, one of my two parabolas to make it my hyperbola, from 4 here and draw it out so that it never touches my asymptote. Okay, so then if I actually graph my problem, my original problem, x squared divided by 16 minus y squared divided by 49 equals 1. There we go. Okay, this is much better than the graph I did. So you can see that my vertex are at 4 and -4. And then if you zoom out on your graph, you can see that your parabola is going to get closer and closer to these asymptotes, right? But it's never actually going to reach them. All right, so then the last thing that we want to do for this kind of a problem is we want to graph it. So we did that. Much better on Desmos than mine. Identify the vertices, which we did. The vertices are at 4, 0 and -4, 0. So that's where my vertices are. I want to find the asymptotes. The asymptotes are at y equals plus or minus 7 over 4 times x. And then the last point are my foci, or my focus points. So remember, your focus points, we're just going to use this equation. C squared equals a squared plus b squared. A squared is the number under your x, and b squared is this number. So c squared equals 16 plus 49. C squared equals 65. So C equals the square root of 65. So your focus points are at the square root of 65 and 0. So if I would put those on my graph, 65, which is about 8.6. It's about 8, right? 6 square root of 64 is 8. So it's about at 8. So if I want to go back here, my focus points are at square root of 65, comma 0. Oh, I can even label it. Focus point. Look at that. And then we also have one at the negative. All right, so that's how we do. It's basically just like how we did ellipses. You're going to follow the equation and figure out where the vertices, foci, and asymptotes are. Okay, that makes sense? Yeah, exactly. So when you look at your homework, the first few are going to be just like this, where you're going to have an equation and you're going to match it up. And then the last two, do you have like 2 minutes? I'll just show you. Okay. The last few are going to be more like they're going to give you the foci, the focus points, and the vertices, and then they want you to find the equation. So it's kind of like working backwards. So for example, if you had, I'll just really, I mean, I'm not even going to like do all the details for it, but if you had number 5 on your paper, yeah, number 5, oops. And whenever you need to go, you can go ahead and go. I don't want to keep you from being late. They tell you that the foci are at 10, 0, and no, 0, 0, 10. See, this happens when I hurry. Okay, the foci are at 0 and plus or minus 10. And the vertices are at 0 and -6 plus or minus 6, right? So just based off of that, just looking at your equation, your foci and your vertex are at 0 something. So you know it's going to be a vertical because your focus is at 0 some number and your vertex are at 0 some number, right? So this tells me my focus point, C, is 10 because I just match up my equation. My vertex, A, is at 6. And then I'm almost there, basically. I need to figure out what B is, right? But I know that C squared equals A squared plus B squared. So if I fill in my blanks here, 10 squared equals 6 squared plus B squared, I actually end up with B equals 8. Okay. And then if I go to write my equation, because what you're trying to do is write an equation, you're going to fill in the blanks. So you're really literally going to fill in the blanks. It's going to be y squared over a squared, y squared over 6 squared, minus. If I did plus, it would be an ellipse. Minus x squared over b squared, which is 8 squared, equals 1. And that's pretty much it. You could make this 36 and 64, but that's your equation. Yeah. All right, so I think you guys should be able to do that. Thanks for coming today, Connor. Have a good day at work. All right. All right, I'll talk to you next Thursday. All right, thanks. Bye.